Hey, how's everybody doing today? Welcome to North Carolina Zoo's Zoo Classroom. I am not Nikki, or Denise, or Donna, or Cynthia, or Megan, or Brittany, or any of them. Anybody met me before? I'm Steve. I'm one of the Zoo Adventures team with Wendy. I'm one of the zoo educators here, and so excited that I was invited to come in and be part of today's zoo classroom experience with you guys. I've never done one of these before. I am stoked to have the opportunity to be here and sharing some really cool information with you. Before we do that, gotta do some rules. The rules. You're muted, all that stuff coming in, so it's easier for people to communicate. However, that doesn't mean you can't interact with us at some level. We'll answer any questions I might have for you. Some communication back and forth in the chat box. In the Q&A box, that's where you're going to ask questions that you want answered. Sometimes my team is going to ask questions right to me. Other times, my coworkers, my friends are going to be typing answers to you in that Q&A box. So in the Q&A box, that's where we're going to get questions from you and answer them either live, or they'll send you an answer. Chat box, when I ask a question of you guys, ask you to do something, or we're having a little bit of a conversation back and forth. Make sense? Chat box, answer, Q&A, question, so we can answer. Sound good? Awesome. Today, animals inside out. Animals inside out. We're going to talk about some of the structures that animals have on the inside and how those structures tell us about an animal's behavior, or maybe even how it looks. Or talk about some things on the inside that might be on the outside, sort of. What are some structures, some things inside our body? What are some structures inside our body? What do we have inside here that we might consider a structure?
Organs.
Organs. Great. Good start.
Says skeleton.
Skeleton. Nice. What everything is hung on.
Got some bones and some cells.
Whoa, going down to the nitty gritty with cells. Awesome. So you guys know, Megan is over here. She's going to shout out some answers to me. So thank you very much, Megan. And right behind the camera is Miss Cynthia. She's kind of making sure I stay in frame and that I bring things to you guys you can see. And we also have Brittany that's going to be doing some other things. She's running a couple of things outside the office for us right now. She'll be back in here in a little bit. Wow. So we have a really big team working to present this zoo classroom to you guys. Animals inside out. Talking about structures of things on the inside. One thing you guys said was the skeleton and bones. And an easy way to look at these, I think, is in the legs, because the legs are really cool. And the bones of the legs tell us a lot about animals. Check out this image. Can you see this image? See if Beth will show us an image.
Oh, yeah.
There you go. See that? If you looked at that, you have a pretty good idea, I bet you, what kind of animal that might be. What might that be? That could be a couple different things.
It's a horse. Oh, and a zebra.
Zebra. Nice. Good deal. And you can tell that. Even if you don't see everything, you can look at the bones, you can look at that structure and say, okay, large head, big body, long legs, some of a tail there as well. So Beth, what kind of picture is it? Let's see what it is. Flip that screen, Beth. There you go. Big old beautiful thoroughbred horse. Wonderful animal. But it isn't always that easy. Look at this image.
Oh, wow.
Look at that skull. Look at that skull on top. That's what one person thought it might be. It's an alien of some sort from distant, distant land. That's a cool looking skull, though.
Oh, somebody says saber-toothed tiger.
Saber-toothed, because you saw the tusks. Yeah. You saw those teeth? Nice. What about the hole in the middle of the head, though? I think it looks like a cyclops monster. That's where that idea of maybe one-eyed animals come from.
Alicia says mammoth.
Mammoth, so very close. Hey, Beth, click that screen one more time for us. Thank you very much. Voila, close enough. Great job. It is an elephant. Look at that. Look at the screen. That hole is where the trunk goes. Whoa. And those two things coming down, those are the tusks. Those are the teeth. So as you begin to look at the skeletons, if you look at them with a critical eye, you can say, oh, they're telling us something about the animal. The skeleton tells us something about the animal. Check this out. Look at this. Look how big. Because I know some of you guys know how tall people are. I'm over 6 feet tall. Look how big that bone is.
Yeah.
We'll keep it up here. I'll go, oh, get up. Oh. Look at that. This is the lower leg bone of a really tall animal. And it fits right into their skeleton. Beth, let's cheat and give them a shot of what skeleton this might be.
Oh, we've already got some guesses.
Yeah?
Got some giraffe.
Very good.
Giraffe.
Nice job, guys. It is. It's the lower leg of a giraffe. But I need you to look at the skeleton. Look at the skeleton. The legs are funky. Those bones are all put together weird. He's standing on his tippy toes. That next joint up, guess what? That's not the knee. That's not the knee. That's the ankle. What? No way. That can't be the ankle. Look the way it bends. Or the knee. Look the way it bends. If you look on the back leg, you see how it bends? Does your knee bend that direction? I sure hope not. If so, you got a problem. You need to go get that checked. That's the ankle. So this is part of the foot. This is what would lay on the ground if we were to sit down. Are you kidding? So you've got to be really aware of what's on the inside and how it manifests, how it shows itself on the outside. Really neat stuff. One of the bones of a giraffe's leg. Got a question, Cynthia?
Yeah, Gracie Sophie is wanting to know.
Hi, Gracie.
How tall can an elephant get?
Oh, an elephant? They can be about 13 feet tall. So I'm a little over 6. That's 2 of me plus a foot. Or 3 feet over a basketball hoop. Or looking almost into a 2nd-story bedroom. That's pretty tall. That's pretty tall. Giraffes are 19 feet tall or 20 feet tall. 2 basketball hoops or looking into a 2nd-story window. Crazy tall. I wanted to show this. This is kind of cool. I think this is kind of share. This is the bottom foot of a zebra. This is real. This is from an animal that passed away at the zoo way before I got here. But the neat thing is that, again, standing on his tippy toe. Do me a favor, everybody, stand on your tippy toes. Tippy toes. Get on tippy toes.
You're almost out of frames.
I have friends that are not getting on their tippy toes here. Thank you, friends. Tippy toes. Get back down. Back up one more time. Tippy toes. Now, imagine you're a zebra or a giraffe or many other animals. That's how you're getting around all the time. You're on your tippy toes all the time, not your foot. Your tippy toes. How crazy is that? I think that's amazing. Do you think there's an advantage of being on your tippy toes? Is there an advantage of being on your toes all the time as opposed to your foot? Is there an advantage? What do you think?
Steve, while we're thinking about that,
Antelope do it too.
Kayla's real curious about how long a giraffe's neck is.
Kayla was?
Yeah.
Kayla, a giraffe's neck can be about 6 feet long. Their neck is as long as I am tall. This is another antelope. You can get an idea.
We have some pretty good guesses
We did?
here.
All right, what we got?
Why an animal would stand on their tippy toes.
So let's hear it. Let's hear it.
Reaching higher.
Oh.
Chris says quieter.
Oh, just smaller footprint.
Mm-hmm.
Nice.
And Corey says can be ready to run quickly.
Good job, Corey.
And I've got a couple of people saying running faster.
Exactly. All those are wonderful answers. I think a lot of it has to do with speed. Think about when you run. If you were to stand up and run in place, maybe you want to try that. Maybe it's an exercise. If you run in place, you don't run on your heels. You don't run on your flat foot. You run on your toes. That helps you go faster. So animals that are already on their tippy toes all the time can run faster. What an amazing adaptation. And if you see a skeleton that has a toe or maybe 2 toes, and you find this bone, and that's what you find, that tells you something about the animal. They might be fast. They might be fleet of foot. They might be a prey item. They might be tall or short, depending on the length of those bones. So just by looking at the leg bone and the toes, tell us something about what's going on. So inside out. What's on the inside can tell us something about behavior on the outside of the animal. But what if it looks so weird? We saw the elephant's skull. I mean, look at this. What? I do know, because I have been on the other side of this program several times. I've been on the side of people who are answering the questions before. So I know some of you have been here before. So some of what you're hearing today might be a little bit of a review or a summary, or some of you might be brand spanking new. Some of you may have seen something like this before. Maybe not all of you. And I don't know that it looks anything like what I thought it would be.
A dino.
A dinosaur? Think about that, though. I love that. Who said that? Did you get it still there?
Leah. Yep.
Leah, imagine if dinosaurs aren't around today, for all intents and purposes, unless you want to go to Bird World. We can talk about that later. It's a whole other program. Dinosaurs, all we have are skeletons, fossils, but we still know how they behave sometimes. We can look at the skulls, we can look at the body, and begin to make those deductions, make those ideas of how that animal lived and survived. So that's kind of cool. Somebody asked a question earlier about this. This is the foot of an elephant replica. This is a replica foot of an elephant. And it's the right size and shape, right? That's the right size and shape. But something seems to be missing. This whole spot back here seems to be missing on this elephant's foot. Because check this out. Beth, can you show them an image, please? Bing. It's so awesome. For you guys back home, our digital guests, I'm actually looking at the same screen you're looking at over there. So that's why every once in a while I look over there. I look over here to see some of I have the slides over here as well, so I can kind of see what's going on. So in that image, you see it's an elephant's foot. And usually there's a big pad down here. It's a big round circle. And you can kind of see that on that elephant's foot. What's missing? They don't look the same. This part of the foot is really full of fat. And it gives it a cushy look. It gives it a smushed down look. You can kind of see it spread out on the image that Beth shared with you. They weigh maybe 6-7 tons for a big male. And those big legs are awesome, but having those feet, large, round feet, spreads out the weight. So they're able to stay on top of the ground. It's said that in the savannas of Africa where they live, it's hard to follow them because the footprints just they're not as easy to be found as you might imagine. I know when I walk across the mud at 300 pounds, I leave some serious tracks. But my feet are smaller, and as I said there, as I put my foot down, my foot's not spreading out. So the weight is on that one spot in my foot. So elephant foot. So you see things, it translates to what you might see on the animal itself. Cynthia.
Well, Leah is curious about how long is an elephant's foot?
How long is it?
Yeah.
You're looking at maybe the size, bigger than a dinner plate. So the plates that you might have dinner on, maybe more like a platter. Looking at 12, 14 inches across.
Family style.
So family style, Megan says. So a little bit longer than a ruler is. That's how wide it would be, and make a circle out of that. A little bit bigger than a ruler, all the way around. And having 4 of those spreads out that weight really, really well, which is kind of cool. How about we meet an animal visitor? Want to meet an animal guest? We're going to talk about something on the inside out. And we have 2 special guests today. We have, who's presenting today? Miss April? Miss April is presenting a wonderful animal. Some of you have met before. I want to don on my mask since April's going to be closer to me now. Everybody else is distancing away. But since April's going to be here, I'm going to put my mask on. How's my volume, guys? In the chat box, because that's where you answer our questions. In the chat box. Am I okay loud-wise? Can you hear us okay? In the chat box. Can you tell me that?
Yep, we're getting some goods and yeses and yes.
Thank you very much for that. So as Miss April, and April is the 2-legged person without feathers that'll be up here in a second, she's going to bring a 2-legged feathered friend with us. And we got a couple things that we're going to share with you about animals inside out. And we're going to contrast, tell the difference between this animal and another animal.
We've got some guesses as to what it's going to be.
Well, we said feathered.
Saw a flamingo guess, an eagle, someone said Tara.
Oh, you guys know Tara, that's right. It's not Tara. She had the day off today. Not Tara. I love the guess, though. Thank you so very much. What do you need from us, Miss April? Besides, you need to be a little quieter. Come on up, then. Let's bring this gorgeous animal. What an amazing animal. This is Braveheart. Braveheart is a red-tailed hawk. April's going to bring her close. How old is Braveheart, April?
I think we're saying 15 now.
Pushing 15 years old.
You lose track after you've been here for a while.
Well said. Braveheart came as a juvenile animal, as a young animal. You'll hear Braveheart him squeak a couple times. That's actually a juvenile sound, kind of begging for food a little bit. April's been working with Braveheart for several years now.
Yum.
The first thing I'd like for just kind of give an idea, I'm not going to ask Braveheart to be doing a whole lot of behaviors. I just want you guys to really check him out. The wing is really cool looking. The wing is really neat. Beth, can you share an image of the wing real quick, and we'll come back to Braveheart. But I just want to show our guests one thing about the wing.
And Natalie's already wondering how long are Braveheart's wings.
We have a Natalie in this room. So,
how did you do that, Natalie?
So I think Braveheart's going to be comfortable with me being behind him. Yeah. So Braveheart's wings are about this wide. Maybe not quite. Maybe about like this. About 5 feet wide. So they're pretty. Well, he's like, Steve, what are you doing? You have no wings. You can't fly, Steve. What are you doing?
We might have to do that again once the screen shares.
Once you're back on the screen.
Yeah. Read the words real quick, guys, on the screen. So in the wing, in the bones of the wing, are the same bones we have in our arms. There's lower arm, there's wrist, there's the ulna and the humor. You see those words? Those are the same bones you and I have in our arms. So we have in this structure some really cool stuff. All right, Beth, you can come back to Braveheart. I want to show. So they did ask. I can't remember the first name. They asked what his wingspan was, and it's about like this.
That is so perfect. Braveheart's like, wait, what?
He doesn't even know.
Maybe 5 feet. Maybe 5 feet wide, plus or minus. But the bone structure, remember we're talking animals inside out, the bone structure in the wing provides that ability to fly. You and I don't have it. We have the same bones, but we don't have the rest of the stuff that Braveheart would have. Is he diurnal or nocturnal, April?
He's diurnal.
Diurnal. And that means active during the daytime, right?
Yep, diurnal day.
DD, right? DD, diurnal day. Thank you, April. So he's a diurnal animal. So he's looking for things during the daytime. And he has an awesome adaptation in his skull that lets him do that. How close? You're going, let's see how good April, let's see how good Braveheart does. You've heard Nikki tell you before, those of you digital guests that have been around for a while, there's a microphone on top of the computer that's shooting this for us. And it looks a little fuzzy, so it might look a little squirrel-like to Braveheart. You see him checking it out every once in a while. But some really good shots there. But what I want you guys, digital guests, please look at first is his eye. I want you to look at his eye, and you see just over his eye what looks like, almost like an eyelid. And I'll get these guys to step back, and I want to show you the skull, which is really kind of cool. Can I trade you places, April?
Yeah.
Thank you very much. Excuse me, Braveheart. I need to take the stage back for a second. Check this out. This is the skull. So as you have it looking at you, see this bone? Can you see this bone? Come a little closer.
There you go.
Can you see that bone? That's just above the eye, right here. This bone just above the eye. That acts like a visor. How cool is that? This bone that's built into the skull acts like a visor. So Braveheart doesn't have to do this. He doesn't have to shield his eyes from the sun when he's looking for prey, because that bone does it. That bone right there does it. And it's kind of hard to see when you're looking. Oh, maybe you can see it. There, right here. Mm-hmm. This bone is broken. This is a replica skull. This is a replica skull. But this is a red-tailed hawk skull. So that's the same size of Braveheart's head. So even though they look a little different, I'll come back here so Braveheart can see a little bit better. You want to look at that, Braveheart? So you get an idea that the skull is covered with, the head is covered with some muscle and those feathers.
It's like, why do you have that?
April's like, what's going on here? Great job. And then this, did he just eat the tail of a mouse?
Spaghetti.
He just ate. Braveheart just had mouse spaghetti.
Yeah.
Nice.
Musketti.
So here again, here's the wing of a hawk. Here's the wing of a hawk. So you guys can see it. An idea of the width. There's the bone. The bones would be in here that you saw. The same bones that you and I have in our arm. How cool is that? Braveheart, the red-tailed hawk, bringing parts of the body from the inside out. The bones, same structure, same bones you and I have, different structure. And then the amazing skull, having that built-in visor over the eyes. Thank you very much.
Everyone is now obsessed with mouse spaghetti.
I have not heard of mouse spaghetti before, but that's awesome. And it makes sense, right? It's the tail of a mouse. And that's part of his diet. It's part of his normal diet, right? And the training that you're doing, every time he does something that's appropriate, that you agree with, that's something that you've either asked for or he's providing in a moment, which is appropriate, you're giving that reward for that, right? So positive reinforcement or operant conditioning. Yeah. Sciencey stuff. Woo! Science. Gotta love it. All right, April, thank you very much. Braveheart can take a well-earned break. You earned some more treats, that's for sure. We have a question to Cynthia.
A quick question from Sienna about how long can they fly without needing to stop?
Hi, Sienna. Oh, you know what? That is a crazy good question. And I'm not 100% sure. Red-tailed hawks are not like some of the soaring birds where like albatross can go for literally days without touching land. The condors can go a long time. Hawks aren't as much of a soaring bird as they are a flapping bird. So my guess would be it's not as long as you might think because they're going to flap, flap, flap. They might soar and go in circles. Kettle, K-E-T-T-L-E, kettle, which is usually vultures, but they're circling, looking for those thermals. They might soar a little bit in there, but how long can they go? I don't have an exact answer for you, Senna. I'm sorry. Maybe some of our friends that are working on the other side of the camera can do that. So awesome stuff. April, thank you very, very much for coming. Natalie, I appreciate your time as well today. And of course, Braveheart being here was amazing as always to see. A couple things I would like to share with you. Stay in the leg moment, stay in legs for a second, is about birds. We saw Braveheart, but we didn't get to see his legs that much because it's kind of short and stocky. Bird you're familiar with is the flamingo. Check this out. I'm gonna come close. Oops, I got pictures on my screen. Bye, y'all. What an amazing team, guys. I don't get to say that often enough. I said, hey guys, I need some help. And they said, we got your help. Amazing. Thank you very much. So here are images of flamingos. Look at their legs. Look at these legs.
Stick legs.
There we go. Look at those legs. They're skinny, nothing to them. And they bend in the wrong direction. You're like, uh-huh. Look at that. So again, you need to pay attention sometimes. Even though you find what's on the animal's inside, how does it work? Well, you can see it's a little bit different here. That joint is bending different.
Jeremy says that looks painful.
Doesn't it? That's a great point, Jeremy. Yeah, it doesn't look right. But it's exactly correct for the flamingo or the ostrich or the robin or the cardinal. Their legs bend backwards. They bend in the wrong direction. That's just the way they're built. That's just the way they're built. You have a question, Cynthia?
Yeah, so we already have questions about flamingo legs, like Kylie wanting to know how high they can fly, and Sienna wanting to know how long their legs are.
Height and length. They can stand, a big flamingo can stand 4 feet tall. So you're looking at legs that are about 2.5 to 3 feet of that, every bit of. And then the head, the body and the head comes up. So they're really tall animals. So you're looking at an animal that might stand this tall. How high can they fly? You know what? That's another question I'm not 100% sure on. They can live at really high elevations. Some of the animals of Chile, the country in South America called Chile, they live at a very high elevation. The flamingos that we have at the North Carolina Zoo are Chilean flamingos. I bet they can fly in the thousands of feet high. That wouldn't surprise me. And they look like a spear cutting through the air when they're flying. They're kind of neat. What's another thing you guys know about flamingos? They stand on one leg. Stand on one leg, guys. Stand on one leg. Megan is standing on one leg while she's sitting in a chair. Megan's cheating.
Only you, Megan.
Right?
I tried.
So flamingos stand on one leg. Do you know why they stand on one leg? Because if they lifted the other one, they'd fall down.
Unless they were sitting.
It's actually very stable for them. This on one leg is more stable because of the way their body is built. One leg is actually more stable, more comfortable than two. How weird is that? So the skeleton, the creation in the inside, the way it's put together, one leg is more stable than two. So flamingos stand on one leg when at rest. How cool is that? What you have, Cynthia?
Well, Tanya's already curious just
Hi,
from the
Tanya.
picture about why are they pink?
Why are they pink?
Yeah.
Because there's a really big pink light? No. No, it's not. That's what Megan said earlier.
Yeah.
Brittany knows, however, that it's because of the food that they eat. They eat shrimp, they eat a lot of crustaceans, and because of that color, the color that's in there, the carotenoids, fancy science word, the carotenoids that are in the food migrate to the feathers of the flamingo. I just learned today, bing, that there are some species of owls that eat lots and lots and lots of crawfish and other crustaceans, and sometimes their feathers will tint the color of the crawfish that they're eating. Just learned that today, about an hour and a half ago.
I wonder if that would work with us.
How cool is that?
Awesome.
How would it work for us? I don't know. I don't know if those carotenoids would migrate out. I think it's more into the feathers that are going into the extremities. I don't think that our hair would pick it up. I don't think. But yeah, it's something to think about. But you might have seen those tests where you put a piece of celery in a water bottle with color and it migrates up and out. So kind of the same idea along those lines. Whoo-wee. Okay, talk about Braveheart. Did that. Look at my notes over there, which are right over Cynthia's shoulder, which is awesome. I want to show you another animal, an animal that flies. I even brought a background that is flamingo, but don't look at that. What kind of animal is this? Which way do I need to go? That way? Whoa, light is reflecting poorly.
Yeah.
Now and then. Well, get rid of the reflection.
Oh.
Come on, Steve. There we go. Right there. Stop.
That's good.
Whew. What kind of animal is that?
Bat.
Be quick before the reflection comes
Bat,
back.
dragon, bird, owl.
Dragon. Love it.
Lizard.
Lizard,
Oh,
bat,
yeah.
dragon. This is a bat. This is probably one of the insect-eating bats. And look at the wing. How cool is this? How cool is this wing? The body here, you can see the body, the legs, down your little tiny tail. But the wing is what I want you to focus on. Okay, this is a little small. Let's do something a little bit bigger. Let's do something a little bit different. This is too small. Let's do something different. That's too small to see. Put that over there. Open this up. Pull this out. Now that's a wing. Whoa. Wow. That's a wing. Flap your arms like a bird. Flap your arms like a bird. It's a big, graceful. Remember we saw the arms in the wing? In the wing, it has the same skeletal structure as you and I. So the whole arm is moving to fly. If you were to flap your arm, you flap your wings like a bat. You don't flap your arms. You flap your fingers. You flap your fingers. They're called little fingers. And that's how they flap. You're saying, I can show you in the skeleton. Fingers. These are the fingers of the bat's arm. These are the fingers of the bat's arm. Animal on the inside, out. The fingers help to fly. So knowing something about how the animal looks on the inside tells us something about the animal's outside. How cool is that? And then this is the wrist, lower arm, upper arm. Wrist, lower arm, elbow, upper arm, shoulder. Flapping their fingers, not their arm. Animals inside, out. Who knew? I knew. Now you do. I think that's so cool. I love thinking about skeletons and what they do and kind of share with us. So the skeleton does one thing, but boy howdy, the huge bone that tells us a lot about animals and how they live is right here. This tells us so much about an animal. If all you find is the skull, you know so much about the animal. And it's true. When you find a skull, you're out in the woods, you're hiking, you're looking around, you find a skull, you say, I don't know what this is. What is this? Well, you do know a lot. That skull tells you a lot about the animal. It really does. You find a skull that looks kind of like this. Might not be this big, but you'd find a skull that looks like this in your neighborhood. You surely could. So I don't see anything that big. No, but you see the right size and shape. You see the right shape of stuff. Look at that. So you found this. You can start thinking, start deducing, start inferring, start guessing about the animal. Sharp, sharp teeth. Well, that tells us that it's at least a hunter.
Andrea says dog.
Dog.
Rebecca says a big cat.
Big cat.
Harper says a meat eater.
Meat eater. Carnivore. So we're getting there.
Wolf.
One thing we got to look at, wolf. So we look at these killing teeth. That tells us that there's probably some meat in the diet. So now I'm looking at probably carnivore or omnivore. So then I look at the rest of the teeth, and I look at these back teeth back here, and I notice that there's no flat teeth. There's no flat teeth. Those are all cutting teeth. So as I close my mouth, as this predator does, those back teeth are cutting even more meat from the skeleton. So those are so the skull is telling you so much about what kind of animal it is. This is a jaguar, a large cat. Well, how come it's not a dog? Dogs are omnivores, so they'd have some flatter teeth back here. Their snout might be a little bit more elongated, pulled forward on a wolf type dog. Some dogs are kind of smushed in, pugs and bulldogs and things. But this is the skull of a cat. Shrink it down, it's a bobcat, lynx, or house cat. Make it bigger, it's a tiger or a lion. But they still have these sharp killing teeth, these molars on the back, carnassals they call them, carnassals. These back molars for cutting and getting more meat off the bone. And then a lot of animals having these incisors to nip and to cut. So we can look at that and go, that's a carnivore first. So I do know something. It's a carnivore or an omnivore. Eyes are in the front. Okay, that tells me something. And the teeth structure tells us something. Cynthia, you got a question?
Well, Tiffany does.
Hi, Tiffany.
She's wondering where we get all these bones and all these biofact type things.
Tiffany, I got to start telling secrets. Don't call me out on my secrets. Tiffany, some of them come from animals that die at the North Carolina Zoo. Sometimes that happens. And if we want that animal to continue educating, to continue sharing its story, sometimes we have folks that will help us prepare those skulls or those hides to use in programs like this. A lot of them are plastic. So we buy them online. We buy them on a catalog. We get them through a catalog. There's different types of companies who sell replica skulls. And replica skulls are much lighter, easier to come by, and don't break as easy. The care that's involved isn't quite as extreme either, so it's easier to tend to and take care of plastic skulls like this black bear, who is an omnivore, who has these flatter teeth in the back. So these flatter teeth, these flat molars, tell us that he's not exclusively a carnivore, that he's grinding up some of his food. He can kill, but he can also grind up berries and fruits and grasses with those teeth. So the skull, again, telling us how they eat. And if we found an antelope or a deer, we can look at no We can look at and talk about the difference between horns and antlers. That's what we can do. That's an outer sheath, and that comes off all the time, guys.
That says, tell Steve not to break things.
Yeah, don't break things, sorry. It comes off all the time. It's supposed to, because we have another story we tell with this one, the difference between bones and antlers, or horns and antlers. But anyway, we're talking more about animal on the inside out this time, looking at these teeth, these, Brittany's down here trying to catch it. These flat teeth, which are all molars and no killing teeth, no sharp canines. So by finding these skulls, we can learn a little bit more about what's going on in their lifestyle. We can look at something very small, and it begins to tell us something. This is the skull of a little tiny jackrabbit. Eyes on the side. Eyes here. We could look at the teeth, but we're going to look at the eyes this time. Eyes on the side. Is this a hunter or is this prey? Is this a hunter or is this hunted with eyes on the side?
Got some prey. Everybody's saying prey. All right.
Nice job. Eyes on the side. I can see more around me without having to turn my head. I can see an animal coming up. If I just stand still as a human, my eyes in front, and you put your hands out like this, you can see about to your shoulders without turning your head. You can do that. It's easy to do. This peripheral vision, the vision to the side, for you and me is about shoulder to shoulder. But if I'm a rabbit and I'm eating grass and I'm worried about being eaten, having eyes on the side of my head, I can see behind me some. The inside of the animal, the skull of the animal, tells us something about the lifestyle of the animal. Eyes on the side, a prey item. An animal that was possibly an herbivore. Now I look closer. Look at the teeth. Yep, that's an herbivore. So much can be discovered by just looking at the skulls. Little skulls, big skulls. How about that one? Eyes in the front, hunt. Eyes on the side, hide. Eyes in the front, hunt. Side, hide. But something else about this animal is this massive hole in the middle of his head. Must be an elephant. That must be where the trunk goes. Oh no? Because he's got these things going on. Looking at the skull tells us something about this animal. Tells us that this animal relies on its sense of smell a lot. We have eyes in the front, hunt, but relies on its sense of smell a lot. Take a deep breath through your nose. Excuse me. Take a deep breath through your nose. Take one more. What do you smell? Megan says from mask. What do you smell? Not a whole lot. Usually it's air. Maybe they've made some popcorn where you are. Maybe there's something cooking on the grill. Maybe you smell some of that. Maybe you smell some perfume, but still not very far away. The polar bear, that skull you just saw, he can smell his favorite food 20 miles away. 20 miles away. So looking on stuff on the inside of the animal is amazing. So much to learn. But you can also look at things on the inside of some animals that are on the outside. Check this animal out. I'm going to bring an animal to you. I got to get dressed first, or I got to put my gloves on. I put gloves on that fit, at least. Remember, we wear gloves to protect the animals from us. Not us from the animals, because our animals that we have here are animal ambassadors. They're great animals. They're used to being handled. And the animal I'm going to bring out, some of you have met before. Excuse me, got a little cough, got a little tickle. Some of you have met the cockroach before. Ta-da! This is a Madagascar hissing cockroach. They do hiss. She's like, what's going on? Here I am. Get you a little bit more in the face. How about that little shot?
So cute.
Ridiculously fun. But the cool thing here is they've brought part of their inside out. What's on the outside of this animal? What's on the outside of this cockroach?
Skeleton, Charles.
Close, 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 close. What's another word for that? I need some more letters on skeleton.
Oh, whoa. Jeremy says exoskeleton.
Nice job, Jeremy. Yeah, the exoskeleton. So they brought, so Charles is right. They brought the skeleton on the outside. It's called the exoskeleton. And that skeleton does a lot of the same thing that your skeleton does. The skeleton provides safety and structure. Just like the skeleton of you and me, the exoskeleton on the cockroach provides safety and structure. So please, please, please don't go around stepping on cockroaches and animals, because that is the skeleton on the outside that unfortunately must break before the animal passes like that. So don't step on them. They do some really important things. I know that Nikki and some other folks have talked about their role in the environment. They're munching on dead and decaying food, turning it back into soil. But we're looking in this program about animals inside out. So this animal has brought the inside out, literally, in that the animal's skeleton is now on the outside of the body. Madagascar, hissing cockroach. What you got there, Cynthia? Cynthia.
So Rebecca has a really interesting question.
Hey, Rebecca.
So does a cockroach have a skeleton inside as well?
Nope, they sure don't. They might have little, you got to try to get away, didn't you? They might have small structures on the inside that might move some fluids, some hemolymph, fancy science word. They might have some small structures like that that help some of that material move around, but not really. They do have some small organelles inside their body, but as far as a skeleton, they really don't. What you see on the outside is that skeleton. That's an interesting question. Mm-hmm. All those hooks and things on the outside of his body, looking at that skeleton on from the inside that's come out, the hooks, he can really hang on tight. He can hang on to my shirt. He can do some really cool stuff, or she can anyway. This is a little small female. Let's see if we can get one more shot.
What do they eat?
They're detritivores, Cynthia. Okay. They're eating dead and decaying material, and they're returning that back into some soil. So they've got a really important job to do, Cynthia. They're eating stuff that's already on the ground. It's already dead and decaying down there. It's rotting. It's going away. So they're able to recycle all of that energy.
And why do they hiss, Steve?
Why do they hiss?
They're called hissing cockroaches, right?
They are. They're called hissing cockroaches, and they hiss for a very important reason. That hissing sound they make, can you guys make a hissing sound? And do it through your teeth. Do it through your teeth. Shh. Do it through your teeth, because the cockroach's hiss comes through little small holes on the side of its body. So it's kind of not going through their teeth, but going through small holes. And they hiss when they've been picked up, when they've been threatened, when something scares them. They make that hissing noise, and if the predator is like, whoa, what is that noise? It startles the predator for a moment, giving the cockroach just enough time to get away, to jump, to climb under something, or to be able to scurry away as quickly as possible.
Very good. Something
else that's on the inside of an animal that comes out. It's a little dark. It's poop. It's poop. fecal matter.
Charles says elephant feces.
Absolutely. But remember, we're talking about how on the inside something coming out and how that tells us something about the animal. Animals inside out is the name of the program. And how looking at that material helps us determine how an animal survives. Well, if we look at the feces of an elephant, and this is very old, by the way. This is probably 12 years old, maybe. This is old. It's been sterilized. It's been cleaned. It's been all kinds of stuff, shellacked and lacquered. So it's safe for me to handle. But if I look at this and investigate it, I can find out things about the animal who provided it, who produced it. I can look at consistency. I can look at what's inside. And the really cool thing, if I look inside, I might find out exactly what it's been eating. And that's cool in and of itself. I know what it's been eating. That's kind of neat. But the other side of that is I can study this and find out what other plants are in the area without going and finding them. Scientists love this kind of stuff. I find the poop. I can find out what the animal's been eating. Voila, science. So it's a study. I can see what's going on. So by looking at what's on the inside of the animal that's coming out, we can learn a lot. But you can't always count on size. This is elephant. This is really hard to open. Oh, because it's a screw top, not a pop top. Smaller, much smaller. See if I can show you in the picture, in the thing. Much smaller little poops. Can you see those? I can't see the screen very well. Can you see that a little bit, Megan? How about in my hand? Can you see
put
it?
it closer. Oh, yeah.
So little poops.
Milk duds?
Milk duds. Who was that really tall animal we saw earlier? What's that really tall animal we saw?
Really tall.
This is the poop of a giraffe.
I just keep getting,
Right.
Is it real? Is it real?
It is real. That's real poop. So you saw that one huge piece of poop from an elephant, little poops from a giraffe. But I can still study those and find out a lot about the animals. So today we've done a lot of animals inside out. Kind of learned some really cool stuff about these animals and what's going on with them. So if you think about finding a skeleton, finding a bone, finding the products, finding the poop, for example, something was on the inside of the animal coming out, you can become little scientists as well. You can become those little conservationists, learning about other things going on in the world just by looking at the skeleton and the bones, which is kind of cool. Trying to follow me?
Yeah,
Yes.
kinda.
You trying to follow me?
Right.
Did you show them my notes? Don't show them my cheat
No,
sheets.
I'm
Don't show them my cheat sheets.
Now they see your teeth.
not. Uh-oh. I'm going back to the front.
But what about an animal like this? What about an animal like this?
Aww.
What's on the inside out? Outside in? The shell? Inside out? What's going on here?
Pretty colors.
Amazing colors, beautiful eyes. Inside out. What's the shell made of? It's hard. It's protective.
The shell.
It's an amazing thing from
is
an eastern
part of-
box turtle.
Krista says the shell is part of their skeleton.
Part of their skeleton. Let's see.
Charles said keratin.
Oh, that's a part of it, but not all of it. Hey, Beth, show them their last slide real quick. Are you kidding me? Are you kidding? The turtle's shell is his backbone and ribs together. The turtle shell is his backbone and ribs together, kind of fused together. Are you kidding? And look at the way the little neck comes in on an animal that's a frightened animal. Of course, Franklin is not frightened. But look at that image. Isn't that so cool? Come back to me, Beth. Where'd Franklin go? Don't worry. Don't worry, Franklin's in my other hand. The shell is his backbone and ribs combined. The shell is his backbone and ribs combined. And there's Franklin again. How cool is Franklin?
Too cool.
But again, finding animals, finding parts on the that are out in the wild begins to tell you something about the animal. And you know more than you think sometimes by looking at the teeth, by looking at the size, by looking at those different parts of the animal. You're able to determine some certain things about the animal. I want to share you one more thing just because it was brought up. Charles mentioned the keratin on the outside of the shell. On the outside of the shell are these. And these are scutes. Scutes are actually modified scales. So animals inside out, you're not looking at the bone. The shell is not the bone because it's covered with a scale called a scute. Can one of my friends spell scute for everybody? It's not like you think. So these scutes are on the outside of the shell. Kind of cool. So that is how we end today's animal inside out presentation. I hope you kind of discovered, you know what, I can see how what's on the inside of an animal translates to behavior on the outside or translates to something that I can tell about an animal on the outside. Do you guys have any questions? I know we've been answering them online. Thank you so much for paying attention to the chat, answering the questions in the chat and asking them in the Q&A box. You guys were phenomenal. I expect no less from you all. I get to see you all the time on the other side of the screen. It's been awesome being on this side of the screen today. I hope you guys have enjoyed today's program on Zoo Classroom, Animals Inside Out, uncovering how what's on the inside of an animal, even if it's poop, can tell us something about an animal's behavior or lifestyle. Thanks, guys. We'll see you again soon.